a separate recordings if you guys want to find the end of that again. Okay, let's flip gears here. So, the next thing we want to talk about, can I get my brain together so I can switch gears? The next thing I want to do is work on some basic vocabulary. And so remember, one of the things I talked about is as we go through these things, we have a lot of new terms that we need to work with. And a lot of that has to do with using these terms for identifying these features that we're going to use to categorize and group these organisms. So we need to really feel comfortable with these terms if we're going to be applying them regularly. So I want to start very quickly-ish with going through what some of these terms are that we'll be using over the course of the semester and making sure we all feel good with what they mean. Okay, so for several of these, what I've done is pulled a bunch of terms out, okay, and pulled them together by the general sort of concept that they all relate to. So these first set of terms, okay, some of which are likely at least familiar and that you may have heard them before, are all related to how organisms deal with body heat. Okay, so let's start with just the first two because they're likely the most familiar. Ectotherm versus endotherm. All right, so we've probably heard at least to some degree these terms before. So ectotherms, this is going to be something like our reptiles, most of our reptiles, not exclusively, or ectotherms. Okay. More classically, we've probably heard the colloquial term cold-blooded. Okay. So when we say that, what we really mean is it's an ectotherm. Okay. So if we break our word down, beep, 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 beep. Okay, this therm is the part of the term that is letting us know heat is at the core of this word. Ecto means outside. Okay, so outside of the body. Okay, so I'm getting heat from outside of the body. Okay, so these are organisms that do not make their own heat. So we got to get it from somewhere else, right? Otherwise we'd be cold. Now animals can't actually be cold, which is where that's a bit colloquial. Okay, but if we imagine something like our little lizard friends, right? When we see them kind of hanging out and chillaxing, okay, they're usually doing what this little guy's doing. Can't see me online doing that business. Go. Hanging out on little rocks or basking in the sunshine, living their best lives. Okay? So they're getting their heat from those spaces, right? From the sun, from the rocks, which are quite warm. Okay? So they're absorbing that heat and taking it into their body that way. Okay? Kind of like a cat basking in the sunshine. Okay, so the opposite of that, well, that'll work too. Then is an endotherm. So here we just see the opposite of the word. We still have that therm core, but now we have endo is the prefix. Right? Think endo, into, or inside. Okay, so these organisms, okay, can get their heat from inside themselves. Okay, so they're going to have some kind of metabolic system. They're able to create their own heat. Okay, both mammals and birds can do this, although their exact system for how they do it is different. Okay, that's not so bad, right? Even though our exact definitions for this might have been loose or unsure, the terms at least have maybe felt familiar. We've probably used the words before. Okay, so let's look at these last two. So far, so good? Okay, so these last two are a little tougher because they're extraordinarily similar. So it's very easy to mix up the way endotherm and ectotherm are used and the way poikilotherm and homeotherm are used. So we're still dealing with body heat. But what we found is we just talked about how our organisms get it heat, right? So I just said we either get the heat from outside or inside the body, right? That's how we're actually acquiring our body heat. As we're looking at 3 and 4, what we're really going to focus on is how are we keeping it? How stable are we keeping it? Okay, so 1 and 2 are focused on how do I get this into my body, or how am I acquiring it? As we look at 3 or 4, so let's start with 3, okay, poikilotherm. Okay, this is probably the least common to some degree. Okay, poikilotherm, so we still have that therm ending, still talking about body heat. Okay, but here we see large variation in body temperature. This would like not be us, right? So these are organisms that can allow huge variations in their overall body temperature. Okay, quite substantial, sometimes 20 or 30 degrees Fahrenheit in body temperature swings. Okay. In other words, the cells and organs in their body are able to compensate or deal with going up and down and up and down. Okay, they can be really, really hot and really, really cold. Okay, so the example I have up here happens to be an ectotherm, right? So they're getting their temperature or their heat from outside. Okay, so if our little fish are hanging out and the water that they're living in gets really, really, really cold, right, I'm getting, as a fish, my body temperature from the water. So if the water gets really cold, my body temperature is also going to get quite cold. If the water temperature gets quite warm, my body temperature is also going to get quite warm. Okay, so most fish are pretty chill with this. Okay, they can get pretty cold inside. Their heart's going to keep beating. They're going to keep digesting food. As the water warms up, they're pretty chill with that. They can warm up. Right, their heart's going to keep beating. They're going to keep living, reproducing, living their best life. Now, this isn't infinite. It can get too hot and too cold. Okay? But the range in which they can live is quite substantial. Okay? Now, I put on here, you see, ectotherm as an example, and I say largely. The vast majority of organisms that can do this are ectotherms, and that makes sense. If you're dependent on the environment to heat your body, the environment is not 1 or 2 degrees all the time, right? So you're going to have to be able to hack a little bit of variety over the course of the day. Okay? Now, this is not exclusively ectotherms. Okay, so for example, I could also say a camel. Okay, camel is a mammal. Okay, it's a furry, milk-producing creature that crosses the desert. Okay, it's an endotherm. Okay, but it is also a poikilotherm, right? Desert temperatures, sort of counterintuitively, do vary quite widely. It gets super, super hot during the day. Okay, upwards of 110 degrees Fahrenheit. But at night, when there's no sun, they can get quite cold, relatively speaking. Okay, below 60 degrees Fahrenheit. Okay, now, while said camel is not getting its body temperature from the air, thankfully for poor camel, Okay, it's still going to be super hard to regulate your body temperature when it's 120 degrees outside and then suddenly 60 degrees outside, right? So poor camel's internal body temperature is also going to do some swinging around, okay? But that's okay for a little camel. Okay, the inside of the camel's body can get quite hot, and it's just going to keep plugging along, living its best life, okay? And it's going to roll up. They live in little herds. They can pack up and stay warm at night, but their body temperatures can also drop much further than ours as well, and they'll be fine. So this is what we're talking about when we're talking about poikilotherms. Okay? Unlike us, which are homeotherms. Okay? Homeotherms need a very stable body temperature. Okay, around some kind of norm. The norm, okay, is just a temperature that may differ per species. So for humans, 98.6, right? We're picky little creatures about that. We break 101, we're sick, right? We break 92, okay, 93. I don't actually even know what the lower parameter is, but it's not very low, okay? You're sick. I happen to know the high one because it's kind of a big deal right now. Okay, whatever it is, you only get a few degrees around it. Okay, it's not 20, it's not 30, it's not even 10. You get a few up and you get a few down. Okay, so this is what we mean by stable. And this is the big difference when we're comparing poikilotherms versus homeotherms. Okay, and again, you see I have, this can be either an ectotherm or an endotherm. Okay, I happen to be showing ostriches here, which are birds, so these are endotherms. Okay, but any species can be picky.
So that's what we can, like, we can hold more temperatures than 100, like outside, just our body regulates to a certain temperature.
So this is correct. So what Maria is saying is we can be in temperatures that are much warmer than 100, but our body is fixing it. So you're exactly correct. And this is the key here. So when we're saying stable body temperatures or non-stable body temperatures, what we mean is the inside of your body cannot break that, right? And so your body temperature can't be. So I can go outside and rock, heaven help me, I can't very well, right? Over 100 degrees. I'm from the north, I am rather delicate. Okay, but I can sit outside when it's warmer than that, sweat and complain about it. Okay, but if the inside, if my cells get warmer than that, right, I'm sick. And that's what this is talking about. Okay, your organs and your cellular tissue are very picky.
Does heat stroke happen when you get, like, is it your cells getting too hot?
Ultimately, it's your body. So I'm working on the mic. So the next question is, what is it that's happening with heat stroke? Is that when your cells are getting too hot? And you're correct. So eventually, your metabolism is working to keep your body cool. And both heat stroke and heat exhaustion is you're losing the ability to maintain that stable behavioral or metabolic temperature, largely because you've dehydrated, okay, or there isn't a way anymore, you don't have enough food or whatever to help continuously cool your body because it is so hot.
And there's something that actually affects your body temperature.
Okay, excellent questions. Okay, any additional questions about poikilotherms versus homeotherms? Okay, so remember, while we're thinking about these two, okay, endotherms and ectotherms, we're really talking about how did I first acquire that heat? Okay, was I making it myself? Right, that's an endotherm. Or was I getting it from the environment? Okay, that's an ectotherm. These two are talking about how am I, or am I at all, right, maintaining that body heat. Okay, do I allow my internal body temperature to vary quite widely? Then I'm a poikilotherm. Or am I quite stable? Okay, am I fussy with my internal body temperature? Okay, then I'm a homeotherm. Okay, so this one, so ultimately, any organism off this sheet should have two terms assigned to them, right? I should have one from the first set. I'm either an endotherm or an ectotherm. Okay, and then I'm either a poikilotherm or a homeotherm. So I have to know how am I getting the temperature in the first place, and then how am I keeping it? Okay, feel good so far? Okay, so now we're going to switch gears, right? Remember, this is sort of an overview of useful terms. So the next thing I really want to talk about is all about movement. Okay, so how does body shape and body form help organisms move throughout the habitats that they have? Okay, so this is just one of our overview slides. Don't panic. Right, we're going to go through each of these terms just like before, one at a time. Okay, so we're going to start at the top. Okay, one of the most common body shapes that we're going to have, or body forms. It's called fusiform. Okay, so you see the word form right in there. Okay, and this fusi is kind of a weird term. Okay, that's one thing. We see this used in like engineering as well, like fuselage, like on a plane. Okay, so it's really just referring to this very streamlined, like teardropped, and kind of point round shape. We see it here on this bird as well. Would have been nice if he worked with me and put his head the way it's supposed to go. Yeah, the key here when we see this very streamlined shape, and we see this quite a bit in nature, is this gives us hydro or aerodynamic capabilities, right? This is going to reduce the amount of friction that we have. So for our fish, right, we're going to get as slick and as hydrodynamic as possible. The water isn't going to push back on as much, so we can really cruise. Same thing with our bird. Okay, we're going to get as little air friction as possible, which is going to allow us the best flight, most efficiency, and best speed. Okay, cars do this sort of same thing, kind of have that smooth kind of top to it. Same kind of idea, improves gas efficiency, improves driving, you get less shudder on the wheel. This is a really popular car commercial thing like 3 or 4 years ago where they always showed them in the wind room. Whatever. That's what that whole hydrodynamics of a lobster picture is about on our homepage this week. That's the whole thing in science textbooks too. There's really popular one of like aerodynamics of a cow. I don't know why people do this stuff, but it is kind of funny to see. So you see a lot of animals, particularly aquatic and flight animals, have this shape because it helps them not get beat up as they're moving around. Okay, so what if I'm on land? It doesn't necessarily help for me to be this shape on land, right? So if I'm walking around, I'm certainly not that shape now, but it doesn't really matter, right? I don't have the smoothest driving experience, I guess. So what does that look like if I'm on land? So there's a lot of different ways that I can move around if I'm on land. All right, so I have two major choices for land movement as I think about these things. So I can be ambulatory or cursorial footed. And this has a lot to do with the way my feet hit the ground. Okay, so if we look at ambulatory, this is the way we walk. Okay, and the key here is toe to heel, my whole foot is going to touch the ground at the whole time at some point in the walking process. Okay, now this is going to make me slower. Okay, but as we're going to find in a minute, there's some benefits here, right? Because I'm getting a lot of connection with the ground, so I have a lot of friction, even in these crap shoes. So I'm getting a lot of push off. Okay, I have a lot of balance, right? Because I have a lot of surface area on the ground. It's harder to knock me over, or whatever that's worth with me. Okay, but it don't matter. Okay, if we compare that to cursorial, and up here I have dog, goat, and ostrich. So several versions for you guys to see what this looks like. Okay, the key here is we are toe-footed. Okay, so what I've done is popped up off my heels. So, heels. Okay, goat heel is like, I don't know, way up here. So what we do with most of these, and depending on the organism, there is a gradient. Okay, but so for here we see toes. Okay, this is the ball of your foot. This is that big bony plate just behind your toes. Right, so your cats and dogs are not walking on their whole feet. Same thing here with our little goat friend. Those cute peetsies. Okay, so here we see with our goat friend. Okay, and same thing with our ostrich even. Oh, let's look down here. Okay, we're up on our toes, and we have less toes. Okay, so the big key with that is we've actually fused toes together. Because if you imagine coming up on our toes, unless we're a ballerina, not since I was 4, okay, balance is probably questionable, and so this is what we're losing. As I'm up on my toes, losing my shoes, okay, I have less foot on ground, right? So I have less friction. Less friction means I'm actually going to be able to run faster. Okay, so most of our, if we think about the types of organisms we're seeing here, either going to be predators, okay, think dogs and big cats, coyotes, wolves, right, cheetahs, okay, or big prey items, goats, antelopes, right, gazelles. So these are runners in the animal kingdom. Okay, the birds we see here, ostriches and emus, these are flightless birds. Okay, you can't fly, you better run. Okay, this goes as well with the small flightless birds, things like cockapos, if you're familiar. Okay, but you have a problem. Okay, being able to run faster is very good. Okay, but we are losing that balance, right? Remember I said one of the benefits to having your whole foot on the ground is you're not going to fall over as easy. Well, now that I'm up on my toes, I may be able to run fast, but if I fall on my hiney, I'm dead anyway, right? Okay, so we want to be like not dead. So there's a couple of ways we can hack this. You can see we have less toes, and what we've done is fuse them together. So we've created a slightly larger surface area. Now, is it the same as a whole foot? Nah, man. Okay, but it's still a big enough area that we're going to get better balance. Okay, and so particularly for our two-footed birds, that's enough. Okay, and with goats and things, because they also have 4 legs, this will definitely keep them even keeled and from tipping over. All right, so with ambulatory, we have increased surface area, increased balance. Cursorial, we have decreased surface area, increased speed. Okay, good so far? Everyone's going to be hypersensitive to walking out of here today? Okay, so what I want to do now is let's really focus on this ambulatory style. Because having your feet planted flat on the ground, while slow, allows us for a lot of adaptation. We can alter the shape of our foot and use all of that surface area, all of that friction to our advantage and do some really cool things with it. All right, so all of these mini versions I have under here are taking flat-footedness and doing cool things with it. So let's look at this first one, saltatorial. Okay, so I'm going to be flat-footed still, but I'm not going to be boring. So instead of just walking around flat-footed, I'm going to take, so let's look at our kangaroo image here. We can see, here buddy, okay, that their feet are flat-footed, right? They've got that ambulatory flat-footedness to them. All parts of their feet are touching the ground at all times. Okay, but they're not just going to like giant kangaroo walk at you, which they can do. They're terrifying enough as it is. Okay, but they've done something really neat. Because they have all of this friction, okay, and their feet touching the ground at all sides, what they can do is use this friction, okay, and this surface area to push off with. And I mean, so can we just kind of look stupid doing it. Right? I'm not a giant red kangaroo that can kick your face off, so it's not scary when I do it. So. Okay, but this is what I mean by saltatorial, and of course you don't have to be absolutely terrifying to do it, right? You can just be a little kangaroo rat from South America and also be effective. So by elongating, see our cute little feetsies here. Okay, these back feet, this is rabbits and hares, right? Less dramatic looking animals. Okay, all we're doing is saying, okay, I get this friction thing, so why don't we use that to the furthest extent of its capabilities. Okay, and that's really going to be the key for all of these. So let's look at fossorial. Think fossils. Fossils are underground, right? So we're going to go underground. And we're going to do the same thing. So let's look at this handsome guy here. He knows what's up. Okay, so again, all about being flat-footed. So now I've shaped my legs into tiny shovels. I mean, tiny compared to us, not on him. They're huge on him, right? Or her, ma'am. All right, so here with our moles, for example, we can turn our feet into shovel-like features. But the same concept still works, right? We're going to stay flat-footed, use all the surface area and the friction on our feet, and use that friction to dig and move earth underground. Okay, so even if they don't look dramatic, like our cute little star mole there, if we look at the naked mole rat, what's up, buddy? Okay, the feet are still very long and flat. Okay, so still using all of that flat-footedness to dig with. Okay, all about monopolizing on that surface area. Okay, lastly, we are going to look at arboreal. So think like Arbor Day, right? Arboreal is going to be things that have to do with trees. Okay, so here again, if we think about things like lemurs or eyes or monkeys, or even our hands, right? Our feet are not well set up for this, but our hands are pretty well set up for this. Okay, this is all about surface area and friction still. Okay, so all we've done now is instead of having straight flat appendages, we still have long appendages, but they're rounded. So we can grip tree branches, okay, but it's just a rounded surface instead of a flat one. Okay, and the idea is that whatever appendage end we're using is going to be in contact with the surface on which we live almost 100%, right? So their feet and hands, okay, are completely in contact with their tree branches, which is pretty much where they live 80% or upwards, depending on the species. So they're using this friction, right, to allow them to move around more effectively. So they're completely flat-palmed and flat-heeled here. That's not crazy. Okay, any questions about any of these? This make good sense? So the key here, really paying attention to what is the benefit of being flat against your environment. Because you're not going to run. All of these guys are terrible runners. Right? A mole is not going to run away from you very effectively. We're not great runners. Okay, so what else is it really, really good at? Okay, so let's take a look at these tree-footed individuals. Because if we kind of picture the organisms that live in trees, okay, it's a lot of weird variety on that as well. Okay, they're not all like our little lemur and eye friends. I'm just going to flip the slide and we're actually going to stop there because I don't think we're going to be able to get through all of them before class is going to end. So we will pick up right here, so don't feel like you need to quickly fill in all the boxes. I already have our Socrative up for today. So the arboreal term is going to be our teacher's question for the day. Please make sure you're filling out the Socrative, right? Last week was the end of last week was the last time that we'll be really flexible about this, right? So we've gotten our practice in, so make sure that you're filling this out. Okay. Once you have everything filled out, on my back 2 rows, you are welcome to go. Please have a wonderful day, and I will see all of you on, let's stop the recording. I will see all of you on Friday.